The key idea in this lesson is, what does slope really represent? What does it represent in all the different relationships that we're going to look at? So slope on a graph is rise over run, or the change in y over the change in x. And the slope gives us information of how fast y changes when x changes, or the rate of change. So the slope describes rate, and it describes rate in the relationship. So some examples of slope are things like velocity. Velocity is a rate. Okay? Velocity is the rate of change of the change in distance between compared to the change in time. So when we graph a distance time graph, so along the horizontal, or x, or my input is time, my vertical, my y, my output is distance. The change in the distance over the change in time is displacement, and that represents velocity. And the velocity in this case is going to be measured in meters per second. So what is the velocity between 3 seconds and 10 seconds? So this section right in here. So our velocity, this section in here, between 3 and 10 seconds. Okay, so we want to find the ratio of change of the change in y compared to the change in x. So the change in y, in this case, is going to be 17 minus 4. So it started at 4, ended at 17. So the change is positive 13. Okay, and then we're going to compare that to the change in x, because the slope is the ratio of this change. So the change in x is going to be, the end point is 10. Remember, the first coordinate is your x. We always start with the y, so y is going to be on top, which is a little bit backwards because the y is the second coordinate. Okay, so we end at 10 seconds. We start at 3 seconds, so my change in time is over 7 seconds. So that's plus 7. Okay, and I forgot to put my units in here. This 13 represents a positive 13 meter change. So then the velocity can be expressed by this ratio. The velocity is going to be 13 divided by 7, 13 meters per 7 seconds. And we can express this as a unit rate by just dividing these two terms. So we end up with a velocity of 1.8, and I'm going to round this to 86 meters per second. Okay, and there's my slope as a ratio. Here's my slope as a unit rate. And we can do the same thing for this next time interval between 10 and 25 seconds. Okay, so we want to measure our change in the y values. Okay, so this is going to be, we ended at 23 meters and we started at 17 meters. So we increased positive 6 meters. So our ratio of change then, we need to compare the change in y. So it's always the second coordinate that comes first on top. It's going to be positive 6 meters. And then we need to compare this to the change in x. So the change in x is going to be between 10 and 25 seconds. So when we subtract the end minus the start, we end up with 15 seconds as our change, or positive 15 seconds as our change. Okay, so there's our slope as a ratio of rise to run. We can simplify that into 2 meters every 5 seconds. Okay. Or we could express this as a unit rate, and again we find the unit rate by division. We just divide and we get 0.4 meters per second. And remember that as a one number rate. The other number is 1. So in this case this is 0.86 meters compared to 1 second. This is 0.4 meters compared to 1 second. And we can see that the speed or the velocity is smaller here because the slope is smaller, and the velocity is greater here because the slope is greater. We want to also find the average velocity between the 2 points, between the start and the end. So the average velocity is going to be the slope of this black line here. Okay? And to find the average velocity, so I'm going to find the change in the y over the change in the x. The change in the y in this case is going to be, we ended at 23 meters, we started at 4 meters. So the change is going to be positive 19 meters. And the change in the time, or the change in the x, is we ended at 25 seconds, we started at 3 seconds. The change is going to be positive 22 seconds. Okay, so that is our velocity for the average velocity from the start to the end. And then as a unit rate, we can just divide those two numbers and we get 0.8. I'm going to round that to 86 meters per second. Okay, and so again, that is, although that's a one number slope, it's all the other number that's always implied is going to be 1. So the ratio of change of distance to time, that is velocity, and we can see that the units are meters per second. And it's a really good idea when we have these word relationships to keep track of our units, because that allows us to keep track of how we're comparing the ratio of change of y to x.